class. Welcome to lesson 11.3, Measures of Variation. As you know, I never lie to you when I tell you things are going to be easy, and this is not one of those times. This lesson is a little bit challenging, so please make sure you pay attention, pause as you go along, go back and check, okay? Please. So first, measures of variation are used to describe the distribution or spread of data. So we've gone over that. Think about variation. We know variation means how much things change, how much things spread or whatever, and measure is how we would measure it. They describe how the values of a data set vary with a single number. A quartile is one measure of variation. So look in the dictionary and find two words that begin with quar. Write two of those words in their definitions. However, I am not going to allow you to use our current word, which is going to be quarantine. Maybe this is with an A. I have no idea. Quarantine. No, we are not using that word, although it is funny. So if I'm thinking of a good word, I'm going to think of the word quarter. And the quarter is, let's say it's, well, I could write it like that. It's 25 cents, which is 1/4 a dollar. Right? Because 25 times 4 is a dollar. What's another word that starts with quar? Now, I know it says to find words that begin with quar, but I think this one might be another one that's helpful for you. What about this one? Quadrants. I'm going to make it look like that so we can tell what it is. Quadrants. Yes. Oh, this one I know has an A. So, quadrants. Remember when we were learning about our graphing, and we learned that a graph had 4 quadrants, right? So on a graph, we had quadrant 1, 2, 3, 4. I know it was a bit weird that it went counterclockwise. However, we know that it split the graph into 4 sections. Also, we know that word let's pretend it's duh, means 4. Quadruplets. We see all of that. So we know that word means 4. So based on that, quartiles are values that divide a set of data into how many equal parts. If you did not guess 4, please go look back and find other words that start with the Q-U-A-R, that start with the quar. Go look in your dictionary. It'll be fun. So, James asked his classmates how many hours of TV they watched on a typical day. Divide the data into 4 equal parts and draw a circle around each part. So before we can divide the data, we have to find out how much there is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Awesome. We've got 16 pieces of data here. Now there's a ton of different ways that you could group it, but I like to group it in the prettiest ways possible. So I'm going to group like this, like this, like this, and weirdly enough, like that. You could have graphed it in any way, although this kind of makes a creepy, cool smiley face. But what we see there, how many data values are in each group? 1, 2, 3, 4. There are 4 data values in each group. Now, is that because we split it into 4 equal parts? No, that's not. It just so happened because we had 20 points of data, 16 points of data. Had we had 20 points of data, each group would have had 5. Had we had 100 points of data, if we split it into 4, just like we mentioned earlier, it would have 25 pieces of data. So, here are more of the measures of variation that we have. So, quartiles are values that divide the data set into 4 equal parts. Just like on our graph, where when we split it up, it's split up into 4 equal sections. If you would like to follow along, we are on page 830. So Then we have the first and third quartiles. This is where it can start getting a little confusing, but hopefully I've made a good example on the next page. So the first and third quartiles are the medians of the data value less than the median of the data value, greater than the median of the value, blah, 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 blah. It's a horrible definition. Honestly, it's just quite frankly horrible. I'm going to have you write down a new one later. Interquartile range. This makes sense. It's the distance between the first and third quartiles of the set. And then the range is the difference between the greatest and least values. So, difference means subtraction. So what that means is we have our biggest number minus our smallest number. So if I were to have you write a better definition for first and third quartiles, essentially it would be the median of all the data below and up to OG median. And then, so this one would be the first quartile, or as we're going to call it, Q1. And then the other one, Q3, is the same thing, but from and above the OG median. So this is what it's going to look like. If we see this, the measures of variation are shown below. So we have our numbers organized. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, because they like to make our lives difficult. Number sets are always better when they're odd to find the medians. So we split the group in two. We find the median. We split it in half. Then we want to split those halves in halves so that now everything has an equal value. All of these are now equal. Not equal in if you added them up to find the mean, but equal in the amount of numbers in the set. So, the median of the data value less than the median of the first quartile, in this case, is 1.5. Once again, this way that they're explaining it, I don't like it. But when we find the median, the way that we find the median, it's either the middle number in a set of numbers from smallest to biggest, or the mean of the two middles, still from the set of data from smallest to biggest. So here, as we see when we split it, we're not pointing exactly at one number. So if we had to find the median for each of them, the median would be the mean of those two numbers, the mean of these two numbers, and the mean of those two numbers. And as we know, the way that we find mean is we're going to add the two numbers together and divide by the amount of numbers. So we've got the numbers 1 plus 2. How many numbers are there? 2. 1 plus 2 is 3. 3 halves, if we made that into a mixed number, is 1.5. So that one is going to be our Q1. Let's look at our median, 3 and 4. 3 plus 4, still just two numbers. We get 7 over 2. If we made that into a mixed number, 2 fits into 7 3 times without going over. That's 6. And then there's only 1 left over. So 3.5 or 3 5/10. That's going to be our median. Then lastly, our Q3, our third quarter, is 6 and 7. Can you take a guess of what it might be? 6 plus 7, still only two numbers. Get 13 over 2. Let's see what happens. Goes in 6 times with a half left over. Look at that. That is 6.5. And that is our Q3. No, our numbers are not always 0.5s. They are not always increasing in certain ways. That's not how they work. But in this case, that is how it worked, just because the numbers looked like that. So here's what we have. We've now organized it. The point of this is that 1/4 of the data is below the first quarter, and that 1/4 of the data is above it. Plus, 1/4 is here, and 1/4 is here. So if we were taking into consideration 1/4 plus 1/4 means that half of the data is between it. Once again, let's look at how that happened. If we just added it up, 1/4 plus 1/4 plus 1/2. In order to add, we need to make sure we have a common denominator. Our common denominator will be 4. Can't simplify the ones. So if we did this, we would get 1/4 plus 1/4 plus 2/4, and we get 4/4. Oh my gosh, that is equal to one whole set of data. Woo! So that's what we find out. Let's look at an example that might help you. Here's our school year. So we have our start of our school year, and then we have our 10-week report cards. That's going to be our Q1. Then we have our 20-week mid-report cards. That's what it's going to be. Then we have our 30 weeks, and then we have our final report card. Mind you, we split it up a little differently, where we call it the 20-week, and then again we start 5, 10, 15 report card. But if we counted the number of weeks in school, the way that we organize it, we would find out that we would have 10 weeks, 20 weeks, 30 weeks, 40 weeks. We know that because we know that the mid is at 20 weeks. So for example, if our median was 20, in this school year case, our median of the quarter 1 would be 10, and the median of our quarter 3 would be 30. Once again, half of our school year happens to be between here, because each is 10 weeks. So the school year is a total of 40 weeks, and the middle between our first and third quartiles is 20 weeks, which is half of 40. So we're going to look at example 1. This one, find the measures of variation for the data. So it says so in the book, so I want you to follow along on here instead. We want to find the range. Once again, the range is the difference between the greatest and the least data values. So our greatest data value here is 70, and our least is 1. They've already nicely put it in this range for us. So we got to find it. 70 minus 1 is 69. Excellent. So that's going to be our range. That's going to be one of our answers. Then we have to order the numbers. Luckily for us, they're already ordered. But unluckily for us, they have an even amount of numbers. So we must find that median number. So let's try to find that median before we do anything else. So if it's between 25 and 30, those are the two numbers that we are going to find the mean of. 25 plus 30 divided by 2. That's going to be 55 divided by 2. 2 can go into 55 a total of 27 times, with 1/2 left over. So if we wrote that as a decimal, we'd find our median is 27.5. However, luckily for us, if we were to split this into 4 different sections, here is our half mark. Now, here is our new half mark right at this one, because we've got 1 above and 1 below. Here's our new half mark, because we've got 1 below and 1 above. So when we have that, we've now found what our median is and what the quartile 1 and quartile 3 medians are. The interquartile range, as we remember from before, is the distance between the first and the third quartiles. So if I had to walk from block 8 to block 50, how many blocks would I have walked? It is going to be 50 minus 8, or 42. Essentially, quartile 3 minus quartile 1. So when we solve this, the range is 69, the median is 27.5, 27 5/10. The first quartile is 8, the third quartile is 50, and the interquartile range is 42. Look at all of these numbers that can be gleaned from just one set of data, most of them not even in the set of data themselves. This, and this are not in that set of data, and it would have depended. Maybe neither would our interquartile medians, just based on the fact that our set of data. So, let's look at this. Determine the measures of variation for the data of these numbers. Now, when we do measures of variation, again, we're caring a lot about medians. So we always have to organize our set of data from least to greatest. If you have the time, I always recommend sorting your list from least to greatest, regardless of what you're looking for. It can help make things easier to count, to see the modes, to do stuff like that. So let's write it from least to greatest. So our smallest number here in this case is 56, then 57, 50, I'm going to write this smaller. So you get 56, 57, 59, 60, 61, because now we've got 56, 57, 59, 60, 61. Oh, I missed one, see? This is why I cross things off the way I do. We make that a 58. 59, 60, 61, 62. So let's see. Let's go back. 56, 57, 58, 59, 60, 61, 62. Now we've got 64, 67, and because I couldn't keep it small enough, just give me a second here. I'm going to shrink it. Look at that. So smart. Let's cross it off here. And then lastly, 71. Excellent. So now we got to find the measures of variation. Let's find our median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Darn it. I hate when there's an even number. So our median is going to be right there. Now, if we were to find the median, it would be the number between 60 and 61. Just like we did earlier, the number between 1 and 2 is 1.5. The number between 3 and 4 is 3.5. The number between 6 and 7 is 6.5. So the number between 60 and 61 is 60 and 1/2, 60 and 5/10, any sort of thing around that line. So that's going to be our median. Now let's find our quartiles. So we've now split it into this set and this set. This one makes it easier. That's only got 5 numbers. So here we've got our Q3 and here we've got our Q1. So now let's look and find all of the different things we need to find. So we've already got our median. We've got our Q1. We've got our Q3, and let's look for our interquartile range. So if we were to find all of those, first, our median, we know that is the 60 and 5/10. Our Q1 is 58. Our Q3 is 64. The difference, if I walked from block 58 to block 64, is going to be 6. And lastly, we have our range. That's going to be our biggest number, 71, minus our smallest number, 56. So this interquartile range, the number between the two of them is 15. Once again, look at all of this information that we got from a set of data. And we weren't even looking for mean. If we looked for mean, that would be another thing that we could add to the set of data. There's so many things we can do with numbers that you would never imagine. And if you're thinking, why don't we use this in the real world? It's actually applicable, especially in banking and trading and stuff like this, in good careers. So in high-level math careers like that, in good math careers, you'll be using this a lot. Accountants, stuff like that. Not saying it's not a good career if you don't. Well, no. An outlier is a data value that is either much greater or much less than the other values in a data set. If a data value is more than 1.5 times larger than the value of the interquartile range, it is an outlier. So we look at our interquartile range and then we multiply it. And if it's that much higher and lower beyond the quartiles, it is an outlier. So let's look at this. This is how I like to remember it. here's this person. Miss Diaz is lame. But they go, yeah, this liar is out because Miss Diaz is cool. Yeah. Yeah. You guys believe that. So let's look at this. First, we want to find the interquartile range. The way that we do this is we do have to organize all of our numbers, again, from least to greatest. Luckily, they already did that for us. So if we found it, we got one number. Let's split it in half. 1, 2, 3, 4, 5, 6, 7. Oh, they love me today. So the number in the middle is that one right there, number 4, because we've got 1, 2, 3 on this side and 1, 2, 3 on this side. So our median is 55, just as a fun fact. So then the one in the middle here is our quartile 1, and the one in the middle here is our quartile 3. Interquartile range. If I walked from block 48 to block 63, my interquartile range is going to be 15. If I multiply that interquartile range by 1.5, so as again, when we multiply, we always line up on the far right. So 15 times 1.5. Move my thing over there. I'll move it over when I get back. 5 times 5 is 25. 5 times 1 is 5. Plus 5 is plus 2 is 7. Magic 0. 1 times 5. 5. 1 times 1. 1. We are going to put the decimal back at the very end. But we get 5, 2, 2. Put our decimal back. So we get our answer to be 22 and 5/10. So then we're going to subtract 22 and 5/10 from the first quartile, and we're going to add 22 and 5/10 from the third quartile. So if we looked at this, our first quartile number as we had it before was 48. So 48 minus 22.5, 22 and 5/10. Now we line up our decimals when adding and subtracting. So here we have to do some borrowing. 7, 10, 5, 5, 2. So 25.5. Let's look at our other one too. Our other number is 63. Since this is our bigger one, we've got to add the 22 and 5/10. Once again, we line up our decimals. This is going to be a 5. This is going to be a 5. This is going to be an 8. Excellent. So any number that is less than this number or greater than this number is going to be an outlier. So let's look. 72, below 85.5. 63, below 85.5. Blah, 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 blah. 23. That's below that 25.5, and we have to have our numbers in a range between these. A number cannot be bigger or smaller than that. So we know then that the only age beyond the limits is 23. So it's the only outlier. Now you say, oh, I already knew that because it looks way different than the others. Yes, but that's not always the case. In fact, we'll run into that a little bit later. So let's look at this. B. The length in feet of various bridges are 88, 251, 275, 344, and 1,121. Name any outliers in the set. So you're probably looking at this and you're going, oh, yeah, 88 and 1,121 are definite outliers. Like, Miss Diaz, what are you talking about? But let's check. So our numbers are already lined up. Let's find where our median is. We've got 1, 2, 3, 4, 5 numbers. Yay! So we got 5 numbers. That right there is our median. It's kind of hard to see, so I'm going to put it right there. The one right in the middle makes it a little difficult now because this is going to be our Q1 and this is going to be our Q3. So 251 plus 88, divided that by 2. When we do this, you can use a calculator. We get 169 and 5/10. Tends to be the case that you're going to get that half when you're putting it between two whole numbers. The other one, we've got 354 plus 1,121 divided by 2. When we get that, we add those together. We get 737 and 1/2. Excellent. So this is our Q1. This is our Q3. And the amount of numbers between the two of them, so the number space between the two of them, if I was going to find that, is Q3 minus Q1. We take away 169.5 from that, and we find out it's 568. So at this point, from our quartiles, we go above and below that. Let's see if it works. 169.5 minus 568, that already encompasses everything. It becomes a negative number. So we already know that everything below that point, this is not an outlier. It works. Then 737.5 plus 568. If we add that 737.5, we're going to get the number 1,305 and 5/10. That's bigger than this number. So all of these numbers are encompassed in our inner quartile range, in all of that we've got. So, or not in our inner quartile range, but it's encompassed in it. So do we have any outliers? The answer is none. We have no outliers. Name any outliers there? None. So let's look at this one. The table shows scores on a science test in 2 different classrooms. So now it looks like we have a lot of data just because we have to do it to 2 different things. But it makes it a little easy for us because it's already doing it for us. Let's find our range. So we find our highest number, 100. And we find our lowest number, 65. So our range, 100 minus 65 is 35. Let's look at the other side. Here, our highest number is going to be this 98. And our lowest number is going to be that 63. So 98 minus 63 is also 35. Is that always the case? No. Just so happened. Maybe someone could have scored a 61 and that would have changed the range. So if we were going to find the median, I really don't feel like putting all of these numbers in order, especially because they're in the book. So the median is 80 for this one. And let's cross off the, we can do it. So we find out the smallest is 65, 100, 67, 92, 72, 87, 78, 84, 80. Let's see what the median for the other one is. 63, 98, 65, 93, 73, let's see, 83, 79, 87, so we get 81 as our answer. So then we have an odd amount of data, which makes it kind of helpful for us. I do want you to pause here and organize the data from least to greatest. I know that the information's in the book, but I still want you to get this practice in because it is hard. I'm telling you to do this. So if I get a Miss Diaz, I don't understand how to do the interquartile range and how to find the median, that's because you didn't do this practice when I asked. So hit pause now and do the practice. Welcome back. If you did not do the practice, I am disappointed. If you did, thank you. So our quartile 3 is the median between those two numbers, or those are the two numbers in the median. We got to find the mean of those, and we get 89.5. Notice that half is common when we have two numbers like that. Is that always the case? No, it is not, because look, on the other side we had 87 and 93, and we get an even 90. That's what happens sometimes. Depends. Now, Q1, we have these numbers 67 and 72. So we get it equal to 69.5. In this side, 65 and 73, we get it equal to 69. All of these so far have been really, really close. Let's look at our interquartile range. It's going to be our Q3 minus our Q1, which is 20. It's going to be our Q3 minus our Q1, which is 21. Honestly, the hardest part of all of this is this part, the median Q3 and Q1. And it's easy as long as we have a good set of data, but if we don't, then it takes just one more extra step of finding the mean, which once again, I'm not the biggest fan of. So when we look at this, if we're going to be analyzing our data, we're going to compare and contrast it. Let's look. Both the classrooms have a range of 35 points, but room B has an interquartile range of 21, while room A's interquartile range is only 20. There are slight differences in the medians as well, just going between literally our median is a difference of 1, our median is a difference of half, and our median is a difference of a half, as well as in the third and first quartiles. But at this point, you can see that both classes tended to fall within the same measure of variation in the differentiation between the two data. Yeah, they did score all sorts of different scores, but on average, they still scored within the same group of variation. So it would make sense that the scores they got are what they did. Let's look at this one. Problem C. So, temperatures for the first half of the year are given in Antelope, Montana, and Augusta, Maine. Compare and contrast the measures of variations of the two cities. So we have to put them in order. Look at that! They're already done for us. Thank you! So we gotta find our median. It's that number right there. But that's fine, because then I've already got our quartile 1 and our quartile 3. You see how easy that was for me to find? So, for both of them, let's split it up into two sections. I'm actually going to split it where? Range, median, quartile 1, quartile 3, and interquartile range. I'm going to pause it so it's going to magically appear. Perfect. So let's fill out the things we already know. We know our Q1 here is 32 and 30 here. We know our Q3 is 70 here and 66 here. So let's look at our interquartile range. Between these two numbers, if I had to walk from block 30 to block 70, is 40. In our other one, if I had to walk between block 32 and block 66, my interquartile range is going to be 34. So if I found the range, again, another really easy thing to do is our biggest minus our smallest. So it's 79 minus 21. So our range for the first one is 58. The next one is 75 minus 28. So if I did this, I would get my range to be 47. So let's find the median of both between 42 and 58. So 42 plus 58 divided by 2 because there's two numbers. When we add these two numbers together, we're getting 100 over 2, which is equal to 50. So as we see, the median here is 50. Our median for the second one is between 41 and 53. 41 plus 53. We still are dividing by 2. There's still two different numbers. We get 94 over 2, which is equal to 47. Now, is our range the same as our median always? No! None of these numbers are ever always the same as one another. So if I'm going to compare the data, I'm going to say here, the range is bigger in Montana for our temperatures. Also, the median is larger, and we've got a lower interquartile, lower Q1, higher Q3, and thus a higher interquartile range. So overall, what that tells us is that Montana, if we looked at all of these numbers and these numbers, it tells us that Montana has a greater temperature variation than Maine does. So let's do the guided practice together. First, this is really easy. Find the range of the data. So we're going to look for our biggest number, which is 11. And we're going to look for our smallest number, which is 7.5. 11 minus 7.5 is 3 5/10. Find the median and the first and third quartiles. Let's see how easy it's going to be for us. 1, 2, 3, 4, 5, 6, 7. Oh, that's so nice. Perfect. So let's organize it. First, let's find the median, crossing off biggest to smallest. And I'm going to do it in a hint way so that we can do it nice and easily. So our biggest is 11. Then our smallest is 7.5. Our next biggest is 9 5/10. Our next smallest is going to be 7 6/10. Our next biggest is going to be 9. Our next smallest is going to be 7 7/10. So we find that our median in this case is 8 9/10. Let's find the Q1. So that's our median, our Q, and then here's how I did it. This is the reason I did it like this. Our Q1, here are the three numbers. 7 and 5, 7 6/10, 7 7/10. What's the one in the middle? Oh, 7 6/10. We don't even need to think about it that much. If we just organized it from small, medium, large. Oh, let's take the medium. So it's 7 6/10. And then lastly, let's look at our quartile 3. We've got 3 is 3. Biggest, middle, smallest. So we know that it's equal to 9 5/10. No, it does not always work out this easily. That is just something really nice that happened. If we found the interquartile range, we would simply do the subtraction. When we do the subtraction between them, we get 1.9, 1 9/10. Identify any outliers in the data. So if I multiplied that 1.9 times 1.5, I'm just going to use my calculator because I don't feel like doing it, but make sure you know how to do it. It's 3.4. So if I add 3.4 to 9.5, I get 12.9, 12 9/10. Nope, all of our data is below that. So let's check. If I subtract that number from 7.6, I subtract that 2 85/100ths from 7 6/10, I get 4 75/100ths. Nope, all of our data is above that. So all of our data is between this. So we have no outliers. There are none in the data set. Excellent. I want you guys to do this on your own. So make sure you hit pause and do this. Numbers are going to magically appear when you unhit pause. Excellent. By now you should have organized your numbers from least to greatest. Here is going to be our medians because we've got an even amount. 25 and 30, we did this before. We found it's 27 5/10. Here, 70 and 75, it's 72 5/10. If you didn't understand that, all we did was find the mean. We added these two and divided by 2. So that's our medians for both of them. Then, what we've got is our Q1, because that's the one in the middle of that set of data, and we've got our Q3s, because that's the one in the middle of that set of data. So if we found that, now I want to find our interquartile range. So the amount between the two of these, between 22 and 40, is 18. The amount between 60 and 75 is 15. And then lastly, I want to see their range. So for their range, 50 minus 15 is going to be 35. In this case, 80 minus 45, our range is again 35. So if we were going to be analyzing this, our ranges are the same. Our medians are very far apart. Our quartiles themselves are very far apart from one another. However, the interquartile range are really close, even though palm trees are much shorter. So what that tells us is the difference in variation between the two of these is actually really, really close. So even though the numbers themselves are not close at all, even though our medians, if you just swap those numbers, they're so different, but we know that they follow that same type of measure of variation, that they're all very pretty close. Your homework is going to be page 833, numbers 1 through 5. If you did not bring your book home, homework is posted in chapter 11 folder in the math materials, and you can get it from there. Make sure you study, as this one is a hard section. Thank you, and I look forward to seeing you guys tomorrow.